Hi students, this is Alex here. In this video, we are going to find the half-range Fourier cosine series for the given function f of x, which is cos h in the interval 0, pi. Now as a first part, we are going to write the formula. F of x is a naught by 2 plus summation n is 1 to infinity an cos n pi x by L, but L is pi, so we get only cos n x. Now to find a naught, we use 2 by pi integral 0 to pi f of x dx, and this is 2 by pi integral 0 to pi cos h ax we have, and we have to replace it with the formula, which is e power ax plus e power minus ax whole divided by 2. Now we can cancel this 2 and 2. Now we left with 1 by pi. Integration of e power ax is e power ax by a plus e power minus ax by minus a. We have limit from 0 to pi. Now we can take upper limit, and before that this a can be taken outside. So we left with e power ax minus e power minus ax. 0 to pi is our limit. Substituting upper limit, we get e power a pi minus e power minus a pi minus, when I put lower limit, e power 0 is 1 and again e power 0 is 1. So totally it is 0. So we left with 1 by a pi e power a pi minus e power minus a pi. But this whole term is nothing but sine h a pi. Actually, if by 2 is there we can write, but 2 is not there. So we have to put into 2 here. So this is 2 sine h a pi. So finally, a naught is 2 by a pi into sine h a pi. So we got a naught. Now an by formula 2 by pi integral 0 to pi f of x into cos nx dx. F of x we are going to replace. So 2 by pi integral 0 to pi cos h ax into cos nx dx, and again cos h ax we are going to replace it with e power ax plus e power minus ax by 2 into cos nx dx. So we can cancel this, and now this is 1 by pi integral 0 to pi e power ax plus e power minus ax whole thing into cos nx dx. Let's multiply this inside and split into two integration. Integral 0 to pi, we have 1 by pi outside, e power ax into cos nx dx. Then again 1 by pi integral 0 to pi e power minus ax into cos nx dx. We are going to apply the integration formula. Whenever we have e power ax into cos bx dx, the formula is e power ax by a square plus b square, a cos bx plus b sin bx plus c. So we are going to apply this formula for both the terms. So 1 by pi we have, this is e power ax by a square plus n square, because b is n here. A is a and b is n. So by applying this, we get first term like this, then a cos bx, so a cos nx plus n sin nx. The same way, coming to the second part, 1 by pi e power minus ax by a square plus n square. Now minus a cos nx plus n sin nx. And here limit is from 0 to pi. Even here it is from 0 to pi. Now when we apply the upper limit, we get 1 by pi. This is e power a pi by a square plus n square, and cos pi will be minus 1 whole power n, sin pi is 0. Minus, when I apply lower limit, e power 0 is 1. So 1 by a square plus n square, and cos 0 is 1, sin 0 is 0. So we have these terms, plus coming to the second set of terms, e power minus a pi by a square plus n square into a, there is a minus a into minus 1 whole power n when I apply the upper limit. Minus, when I apply lower limit, 1 by a square plus n square into cos 0 is 1, but we have minus a, and sin 0 is 0. So we completed the substitution of the limit. We can take 1 by pi common throughout. Then from the first set of terms, we can group e power a pi, but we can also take a common from these two terms. So a, or else first we shall rearrange this one. So e power a pi into a into minus 1 whole power n by a square plus n square we have. Then let's write this one, plus e power minus a pi minus a minus 1 whole power n by a square plus n square. Then this second term, which is minus a by a square plus n square, and this one minus minus it becomes plus, so a by a square plus n square. So we can cancel this minus and plus terms. Now further rearranging this, we get 1 by pi, and we can see the common denominator, even that can be taken outside, that is a square plus n square. After that we have e power a pi into a, then minus 1 whole power n. Then here it is minus a into e power minus a pi into minus 1 whole power n. And we see a is common, and minus 1 whole power n is also common. So a into minus 1 whole power n by pi into a square plus n square. After taking common, we have e power a pi minus e power minus a pi. But this whole thing is sin h a pi with 2 times. So a into minus 1 whole power n by pi into a square plus n square. This is 2 into sin h a pi. So finally we got an. After getting a0 and an, we have to substitute that in the f of x formula. So f of x equal to a0 by 2. a0 we have 2 by a pi into sin h a pi. So 2 by a pi into sin h a pi by 2. So we put 2 here, plus summation n is from 1 to infinity a into minus 1 whole power n by pi into a square plus n square into 2 sin h a pi. So whatever into cos nx. So we can cancel this 2 and 2. Now f of x becomes sin h a pi by a pi. Then from here the constants can be taken outside, which is 2 sin h a pi and whole divided by pi. This can be taken outside. Now summation n is from 1 to infinity Even this a can be taken outside. So I take 2a here. So inside the summation we have minus 1 whole power n into cos nx whole divided by a square plus n square. This is the required half range cosine series for the given function f of x.